Right, so this thing here arrived in the mailbag recently, so I thought I'd just do a little review on it. Okay, so I've seen this on someone else's channel. I think it might have been Voltlog or maybe Jan Bedo, I can't remember. It could have been Big Clive actually. Actually, yes, Big Clive, his channel. So this is a little UNI-T clamp meter. So it's the UT210E, or 210E, 210E, right? True RMS 2000 count, apparently. We shall see about that. I've had a little bit of a play around with it, but I thought I'd just demonstrate it, and I may even open it up. I might do. Yeah, what the hell, I'll open it up. So I'll do that afterwards, because unlike Dave, I want to make sure it works, so I'll pull it apart. Now, I already have made sure it works anyway, but for the sake of the video, you know, yeah. So it comes with these little leads as well. I mean, it's quite a nice little bag for this actually. Instructions, you know, like you kind of need them anyway, but you know, it's got specs in there, I'm sure. Yeah, got various references, and there you go, symbols and specs and stuff like that. Specs, where's the specs? Here we go. Alright, so 1% accuracy on ohms, 1.2% above 2 mega ohm, 0.7% accuracy, plus 5 counts, plus 3 counts and stuff like that. You know, it's on millivolts DC, or millivolts and DC. AC 1% plus 3 counts, 1.2% plus 3 counts, 200 volt range. You know, it's hopefully you can actually see this yourself anyway. Alright, but that's the specs for it, so it's not too bad. I mean, it's okay, you know. For something, you know, this small and convenient to carry around, you know, it's you know, certainly reasonable, accurate enough. You know, you don't need super precision if you're just doing something portable. Usually, you just need to make sure something's actually working or doing something like it's supposed to be doing. So, oh, now I've got to try and fold this back up again. There we go. Right. So, first things first, turn it on. So this has got. Let's see what lights. Is it reflecting? No, it's okay. All right. So it defaults to AC when you turn it to voltage. Then you push this button here, it goes to DC. Back to AC again, right? AC RMS or TRMS it's got up there, just to remind you. Alright, got zeroing as well, which you expect. But to clear zero, you can't just push the button again. It just re-zeros when you push that, so you just have to push that selection again for the actual mode. Also, it's got hold as well, and it has a light apparently. There we go, there's a light. You may not be able to see that in this lighting, but it's there. Okay, so you know, that's convenient if you're working in something in this bit dingy and dark in a cabinet or something. You know, back of a car or something like that, who knows. Alright, so that's okay. This zone is defaults to resistance on change. So it's mega ohms, then ohms, then diode test, then capacitance, back to ohms again. Well, mega ohms again. Right, so it's got dual scaling of resistance. Actually, that one there's the sounder. I shall recorrect that. So that's normal resistance mode. That shows ohms with the sounder. So that's the diode check. That's the continuity test. That one there, which gives you resistance measurement at the same time. I should probably use left hand so you can see the screen actually. So that's diode test there. All right. Amps again, it defaults to AC. To me, I don't do much AC work, so anyway it's a bit annoying. It always defaults to AC because I'm always going to have to change it, right? So that's DC there. Now, obviously this is just through the clamp attachment. But the reason I purchased this is not only because it's small, but it's also, it does 2 amps full scale, right? Which means you're getting milliamps readings on here using a clamp, which is what I liked about it, you know. You don't have to, you know, break into a circuit and clip some leads in, or you know, cut a wire, or you know, desolder something, or remove some connector or something like that. You can just clamp it on, right? And that's why I got this, because the stuff I do is usually low current, pretty much, you know, less than 10 amps, pretty much all the time. All right, so I've got another clamp meter, a Digitech one, this generic one from JK Electronics. and that's okay, but its lowest range isn't good enough. It's like 200 amps or something. It's like, well, you can't get the resolution. You're trying to do small readings, which is what this can do. Alright, so you've got 2 amps AC DC, 20 amps again default to AC DC, and 100 amps AC DC. Alright, so, and also got NCV, which is non-contact voltage. So it just warns you if there's AC around. I don't think I've got anything. This might do it. Here we go. Alright. Let's move this over. This is my extractor fan cable. Alright, so this warns you if there's high voltage in a cable or something like that, which is, you know, handy as well. Alright, so that's not bad. Not a bad little feature set. Okay, so what I'm going to do is I'm going to show you, let's go through the scales. Let's do voltage first. Alright, we'll do voltage measurement first. I don't have any AC voltage references. I do have a DC voltage reference, you've just seen me recently working on. But it's way above what this thing's resolution is anyway, so there's no point in me digging it out. I'm just going to use a power supply. I know the power supply is fairly close, it's not 100%, but it's pretty close. Alright, so I'll choose mine leads instead of these ones right now. I will get to those. Alright, so let's turn it on. Now, in this case, it's default to the AC, but it's getting a DC voltage, and so it doesn't like it. Alright, if we go to DC, and there we go, I'm putting out 12 volts right now. Alright. If I can verify this voltage on my other meter, actually, I'll tell you exactly what it is compared to my other meter. My other meter says exactly 12 volts. Alright, so this is slightly off, maybe. It might just be a zeroing thing. So pull the plug out. It's obviously picking up some stray stuff from both of them. What the hell? Alright, it's zero anyway. I think zeroing also locks the range it's in. I did do some tests before when it went over range. So there you go. See, it locked the range. Alright, so if you're trying to zero on a zero and then get the exact reading, it'll go out of range, and a bit of a pain that way. Alright, so that's one thing you have to watch out for. But yeah, it's close enough. I mean, 10 millivolts out. Yeah, it's alright. Okay, so let's change this voltages. Let's go to 1 volt. And there you go, exactly 1 volt. So that's actually right down that scaling. 5 volts, fine. To 20 volts, yeah, fine. 30, yeah, okay, it's rescaled, but that's okay. Look, it's now showing reasonable resolution. Now, what's that rescaling point? I think it's about 2.7. I think it depends on what function you're in at the time. There we go. So that is actually, yeah, that is 2000 count in that one, though, right? It's stated as 2000 count. When I was doing some the ammeter testing, it got to 2.7 before it rescaled. I thought that was quite interesting. Alright, so I'm doing 19 volts right now, and you can see it's out by 20 millivolts. I mean, yeah, it's not super accurate, you know. It's okay, alright. It's within, you know, I don't know. What is it within? I'm trying to think of some analogy, but I can't think of one right now. It's too early. Alright, so yeah, it's close enough. Alright, for most stuff. If you want more precision, you wouldn't use this meter, you know. But for voltage measurements, it's not what you want it for. You know, it's just a handy thing for the clamp meter to be having. You know. Alright, so that's voltage. So I can't measure any of the AC stuff because I've got nothing set up here for that. I don't actually have an AC reference. I would like to get an AC reference. In fact, I'd like to get a broken AC reference, repair it in a video, and then keep it. If anyone's got one that's broken, they want to give me, you know. Yeah. Anyway, right. So that's that. Now I want to do next one, which is the other option. So let's disconnect this. All right. So what we got? Resistance. Yeah. Well, I've got no resistors here. I could use probably. Let's get the original leads out. Let's have a look at these. This is what had them out for ready to go. I mean, these aren't silicon leads, they're PVC leads, you know, so they're not as nice in that way. They're okay, but you know, I much prefer silicon leads. Anyone that's ever used silicon leads will say, yeah, they're better. You know, they don't get tangled as much and that sort of stuff. I mean, look at this. I mean, they don't want to come back out of that shape, for example. So, and of course, they come in as little plugs to keep things round when they're in storage, and yeah, as they always do. So, anything plugged in would be good. Right, so they've got these little shrouds on the tips, which is nice. It's nice to have that. Yeah, it's a nice feature. Tips are not sharp; they're actually quite blunt. Yeah, so not at all sharp. I don't like the leads. Okay, if you got leads, maybe just, you know, I don't know, sell these with a piece of test gear you're flicking on and get some decent silicon leads with decent probes. I mean, these are, they're just budget. I mean, UNI-T branding is, it's a bit hit and miss. I mean, they've got a okay-ish reputation. They're not regarded as being great or good. They're regarded as being okay. At least from what I've seen and from my own experience with their gear. I mean, it works. It does a job for most people. If you don't look into it too deeply, it's fine. But when you start looking at the detail, then it's like, actually, you know. I mean, it feels robust enough and stuff like that. It doesn't, you know, it's a nice robust case. It doesn't twist or anything, you know, things like that. It's all good, but you know, I'm not going to destroy this to demonstrate things to you. I want to use this, so I'm not going to break it or anything like that. So. All right. So ohms. Let's find some kind of resistance I can use. This is nowhere near accurate. There's no precision things in there. Actually, where is that? Actually, I can do better than this. I can do better than this. Hold on a second. Actually, no, I won't use that. I'll use one of these. It's overkill for this thing, but you know, you want to know you're definitely measuring the right value. So we have some Vichy resistors, or Vichy resistors, sorry. Vichy is something completely different. Right, so this one here is a 15 ohm resistor. So let's just probe on there. What we get? 15.2, 15.3. Oh, it's going up. Look at that. Maybe it's just bad contact. Hold on. I'm not getting a great connection here. Come on, get on there. 15.1. Yeah, okay. Point one out again. I'm seeing a trend here. This one here is a 20 ohm. And that's measuring okay. I mean, yes, right. But it works. And obviously I haven't zeroed it. I probably should zero actually. That's a bit of a glaring negligence on my part, isn't it? I didn't zero the bloody thing first. Hold on. It's saying 0, yeah, so yeah, don't worry about it too much. Okay, so actually, yeah, I will get this thing out. Now, this is a little test unit I built some time ago. I basically, I'll put the tape back off again. It's a resistance box. Probably should use proper leads to these, but this will be good enough. Right. So let's see how good we get. I mean, this box isn't that accurate. You got some losses in the switch and stuff like that. It's more of a relative measurement thing. But I try to make it more precise than the other one I had, right? Which is, as you saw before, this thing here, all right? Which is okay if you're just trying to do a quick substitution. But yeah, this has got 1% resistors in it, and this has got 5%, I think so. And these ones I've handpicked all these resistors to be as close to value as possible in order to get the readings correct. But anyway, we'll see. So that's 1 ohm, 2 ohms. At these low scale readings, it's off by a little bit because of the switch resistances and stuff like that. So You can see they're all going up by basically 1 ohm, right? So you can see they're all pretty much 1 ohm. But I've got half an ohm resistance also in actual circuitry, right? So as you can see there, I can't get rid of that obviously, it's just the way it is. So if I allow for that extra offset there, do 10 ohms. Alright, so these are all fine. So this box I made, so it's not going to be exactly perfect. Basically I bought a whole bunch of resistors and measured them, and I found the ones which had the best values for the most accuracy and put those in this box. So you could have used 5% resistors, even 10% resistors if they even exist. But the point there was to get the value correct. The quality of resistors is probably more important than anything else, but I did buy good quality resistors for this. Alright, so yeah, you get an idea, don't you? I mean, its response time's not too bad. It's fairly fast. It's not like awesome or anything, but it's okay. Alright, so that's it rescaled there. So I'm just going up through the K's. Yeah, it works okay, doesn't it? 10k there. Again, it's off by that least significant digit. So in that case, I'm not going to go through every single one. So that's 100k there. I mean, it's off a little bit. Some of these values I'm actually a little bit worried about because I think they might be a little bit wrong. I need to do some more. I think this end was a little bit off. But yeah, it's more of a comparative thing. That's what I built this for, so I can do comparative values and substitutions. So that's 1 mega ohm, 2 meg, 3 meg. There we go. Alright, so I can go up to 9. All the 9s, right? So that's all the 9s, which then gives me a slightly higher reading of 10 meg there. Alright. Yes, but I mean, again, you can take that a bit of a pinch of salt, really. So I'm dropping these values down. It's not changing by a huge amount. But yeah, I'm not quite sure about the accuracy and of that higher range. But anyway, yeah, it works. Okay, so it's reasonable. It's within, you know, a gnat's whisker. I don't know what you want to call some kind of bullshit thing. Right, so yeah, it works. Right, next range is continuity. Continuity, how you want to pronounce it. Yeah, it's not bad. It's not the fastest I've seen, but it's not bad. There's not much in that. It's not bad. That's acceptable, certainly. It's you know, that's better than some more expensive meters I've seen. So, okay, next thing we got here. Diode test. Yeah, well, let's find a diode. Okay, just a 1N4148 diode, so here we go. Nothing that way. 0.6 that way, yeah, that seems fine, doesn't it? It works. And what's the next thing? Capacitance. Let's just do electrolytic, can we? So this is a 4.7 UF. .4. I don't know what frequency this tests at, because that affects electrolytic capacitor readings. Let's see, can I find it? AC/DC instance. Capacitance. I don't see what frequency it says it uses. Don't know, maybe someone knows. Maybe someone knows what frequency it uses. Maybe I should actually try and test it. Let's write this code and see if I can read it. I've never done that before. So this could be interesting. Let's see if we can find a reading. Just out of interest. Be nice to know, wouldn't it? Can I measure a frequency on this? Yes, I can see a frequency there. The frequency is 4.6 kilohertz. Interesting. Okay, 4.6 kilohertz, it measures that. So, now you know. Right. Let me copy it. So I did that. Let's try a larger value. I'm not sure what value it can go up to actually. That's a bit of a good question. Yeah, let's try 1000 UF. Although with that frequency, who knows what we're going to get. It's 3.5 MF it says, so that's very different to the marked value because of that frequency I expect. So if I'm doing a lower value, it might be a bit more accurate, more suited to that kind of style. So this one is a 1 UF. Bloody leads are tangled up because those. Anyway, right. There you go, 1 UF. Right, so the frequency is more suited to smaller capacitor values. You know, if you've got larger capacitors, it's usually like more suited to 50 or 60 hertz or whatever. You know, it gives you more accurate readings then usually, or even 1 kilohertz frequency would have been better, or 100 hertz. So yeah, so probably not suited to electrolytics unless you're doing small value stuff. Because yeah, I don't know. I think there's a way of changing the frequency and like that. So I think it's pretty much what you get. So that's all those. Now, current measurements. Again, defaults to AC. So I want DC measurement there. Now what I'm going to do is hook up to my benchtop power supply. Not those cables, not the other cables. What I'm going to do is, these are hooked up to my power supply. It's just short them out, so let's make sure I've got current and stuff aren't too high. On there, yeah, I'll drop it down a little bit. Right, so 100 milliamps is what it's currently set to. As you can see, there's a reading on there, so I need to zero that. Again, if you're trying to do a big value, if you zero that, it locks into the range, so not the best. No, it's saying 400. I did this differently before. Hold on, let's turn it off. Do this again. Use my left hand so you can see. Right, zero that, then turn it back on. There we go. Right. So 100 milliamps exactly, which is what my power supply says it's doing. Right. So it's just wind this up. 500 milliamps. Yeah. 1 amp. Yeah. Okay. 1.5 amps. Yeah, it's alright. Go 2 amps. Right. 2.5. Now, because I've got that zeroing there, it's now gone over range because it's locked the ranging. So now I'll turn that auto ranging back on. Let's drop this back down. Alright, so there's 2 amps there. Was it not going? Oh yeah, it is though. Interesting, before I was getting it going up to 2.7. Now it won't do that. Let's just change the polarity. There we go. Oh no, it's changed slightly there. Doing 2.1. That's interesting. I saw it do 2.7 before when I was playing around with this. I'm not sure what the difference is, but even now it's saying 2.1. We're supposed to be 2000 count, so yeah. Maybe that's a little bit inconsistent. Anyway, let's take lighting back up the power supply before I blow the thing up. Right. Yeah, I mean it does work okay. Actually, I can go up to 5 amps on this. Let's quickly do that very briefly. Right, so we go right up. That's 3 amps there. Oh, because I need to go to the next scale up. Sorry. Oh, it's not AC. Sorry, default to DC. It would be nice if default to DC. Anyway, so that's 2.5 amps, 3 amps, 3.5 amps. So let's turn it off again. Let's do some zeroing. Turn it back on. So it's slightly off. 4 amps, 4.5, 5.1 is the most I can do with power supply. So yeah, let's back down again before I damage something. Don't really want to do that. Okay, so yeah, I mean it works. And we'll do this range as well. Do a zero on that, even though it doesn't seem to matter. Do that. Okay. Can't have the current set at 400 milliamps, doesn't show up. 1 amp doesn't show up. 2 amps doesn't show up. Why is that not showing up? I'm now doing 5 amps, it's not showing up on the meter. Maybe it's just below that ranging. No. That's interesting. Hold on a second. AC again. It caught me out again. Okay, this is going to get annoying very fast for anyone who uses one of these things for DC work. Okay. It'd be nice if it's auto switching between AC and DC as well. If it detected which one it was, that'd be nice. Okay, up there. DC 5 amps. Here we go. All right. One amp. Yeah. 500. 0. Yeah. 3.7. Yeah, I mean that works okay. I mean it's obviously just low and low range stuff, but also conscious of not damaging my power supply at the same time. Okay, so yeah, I mean it does the job, doesn't it? It's just that little annoyance here. It always defaults to DC, to AC. In my case, for me that's annoying because I do DC work mostly. People which do AC work, it's going to be fine for them. But yeah, I mean it's okay. Also, that non-contact voltage thing I would have showed you, although you know you can do that too with your hand, you know. Yeah, it's okay, isn't it? You know, it's not bad. It works okay. So I'll stop this for a second, and I'll start pulling it apart. Just right. So a bit of a tidy up. Now I can carry on. So let's get this thing apart and see what's actually inside it. See what the build quality is actually like. So. First is battery compartment. Now it's got a nice threaded insert in there for changing the batteries, which is nice. You know, it's not self-tapped or anything, so you know it shows a little bit of quality there. It didn't come with batteries, unfortunately, but then I got it from China, and sometimes I don't like to ship batteries, I think. So yeah, it's all right. So yeah, it's a nice threaded insert, and the battery fits all nice, and it's nice and easy. No external fuse access. I'm assuming there's fuses somewhere. So we'll find out what it's actually like inside here. These are obviously self-tapped, but that's fine. I mean, these aren't really designed to come apart over and over again or anything like that, so self-tapped is fine for that situation. Okay. There we go. So we've got some nice stainless, or stainless? Not sure. There might be nickeled, probably nickeled. Just a couple of contacts here, which then push down to the board just here. So that's all fine. There's a little flat flex cable here, which is all very interesting. Right, well, what we're looking at, there are no isolation slots in the board. I mean, you obviously got some input protection here, but there's no isolation slots. And how far am I going to pull this thing apart? I don't really want to break it. There's a soldered wire there which goes up to there. There's a sounder. Let's see what's that chip there. It's got some trimmers on here. A couple of trimmers just there. Just like the only ones on the board. There's actually a what's that? There's a capacitor marking there which isn't populated, which is a little bit interesting. So what we've got chip wise. Oh, it was the right way up. Now got the lighting on, I can see it. Okay, so we got, what the hell is that? I don't know. It's the top line is 04330A. Second line down is 68K. And it's like G4, which is underlined in smaller text. And C174 underneath that. I've got no idea what those markings mean. No, I don't know. It's not my thing. It's more for people which are interested. And this one here is more obviously marked, which is a DM1106EN. I don't know what that is. It's probably some generic multimeter thing. Maybe it's a UNI-T one, I don't know. But there's no branding on it. But yeah. And then here's another chip, which is, if I can get the lighting on it, a T210E. No idea what that is either, but someone who might be interested. Okay, so obviously got some protection here. Varistas and MOVs. But I'm surprised there's no kind of cutouts in the board for isolation, which I would have expected a little bit as soon as it's supposed to be. Cat 2, Cat 3 to 600 volt. I mean, well, Cat 3 to 300, Cat 2 to 600. I expect some kind of protection in there for that. This is the thing I've seen with other UNI-T reviews, where this is what seems to let them down, as the input protection side of things. You know, yeah. I mean, it's all double insulated and it's all fine in that regard. There's no, I mean, there's a metal contact here, but you're not really likely to be touching it, are you? In the jaws, there's a screw there which goes straight through. There's nothing on it which could possibly cause you to come in contact with it. So having AC potentially come through the digital circuitry is obviously going to be bad for the digital circuitry, but it'll just blow it up. It wouldn't actually cause you to become injured, I don't think. But if there were a big short, a big fault current coming through this, it's going to not be good, because there is no isolation there and it's going to track. Now, how far am I going to pull this thing apart? That is the next question. Now this is attached, that's a separate piece, so I can take that out of the board. There's a wire there which I can't determine where that goes. There's an LED at the top, might be part of that. I don't know risk breaking this. If I break this, it's YouTube's fault. How's that? There's a nice big spring on there. That is a threaded insert, because that's a nice machine screw. So let's see how we go as far as getting this apart without having it pinging everywhere, hopefully. Is this going to come out? No, there's another screw somewhere. Now that is just a push for internet connector. Hopefully I can get it out. There we go, that's why I work. Do it this way, end to end, hopefully. So I don't want to break this meter. I want it to work again. Alright, I purchased it for me. So there's a little wire that goes down there. So it's all a little bit intriguing. That's soldered on, so I have to be careful with that. I don't think I'm going to get the jaws out somehow, so I might just leave those in after all. I'm not going to pull that out, because that's spring and it's going to be, you know, big tension and fiddling around trying to get that back in. I'll leave that out, but I will take the board out. That bit looks like it's promising. Screw there, there's a screw here. Screw there. It's interesting, they've got different screws. These ones are longer. So there's a couple of shorter screws on it. Obviously they didn't allow for the depth of the casing. Another screw up here. Okay, so that's a black screw there, silver, silver, silver. And I think, oh, there's another black screw just down here. So there's plenty of screws holding the board in. Okay, so that's black, 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 silver, silver, silver. Right. And here we go, there's the board. There's a display. Just fell out. Or display backlight part. And it is on a zebra strip too, so that could actually fall out if I'm not careful. So I want to be a little bit careful with that. So there's a backlighting part, and there's a display on a zebra strip. Yeah, I won't take that off. There's nothing really behind it. There's a couple of capacitors and resistors. Right, so let's just drop this back in there. It's got a little cutout there. There's the LED. Nice little cutout there, so it can shine the light through the assembly there and diffuse the light behind the display. Let's pop that back in. Like that. Okay. So just the 3 buttons there, and obviously the switch contacts, which are fairly close together. There's a little bit of residue on that one actually. That one looks a little bit dirty. I might. I'll see right. That's right. I'm thinking to myself now. So it's actually marked on the board as well. What they are: select, VFC, 0, hold, backlight. It's actually marked on the board, so I was quite surprised by that. LED there, which is that one which is on the front panel. There's a little light tube assembly just there, so I'll shine that through, which is for the VFC indicator warning. Little perspex assembly here. Okay, is it? Oh no, it's polycarbonate. It's PC. It's polycarbonate. So okay, that's fairly scratch resistant and stuff like that. It's not bad. Buttons, nicely moulded. Very nice, and it's actually got carbon inserts on the end. That's a nice molding process actually. That's 3 shots in one. It's quite a good technology. Basically it's got 3 injection units and it injects 3 colours at once into the same mould. It's quite impressive. Casing, I mean, yeah, it's alright. In this, a part like this, you can see the flex in it, but when it's together it's really rigid. This one here again, that's quite rigid there because it's got a lot of bracing around the battery compartment. Can I see? That's ABS. PC ABS. So it's a mixture. It's got a little indicator here which you can turn around inside the mould and you can point it to which version you're making, which material. And it's marked as PC/ABS, so it's polycarbonate ABS blend. So yeah, that's polycarbonate be giving it stiffness, ABS be impact resistance. So not bad. And this one here has got the same arrow and pointed the same material, so that they correspond at least. Now there's also date stamps in them. Now I'm just trying to read it. Very small. These are date stamps. Alright, so that one's 16 and that one says 7. So it's made in July 2016. At least the casings were. This casing was. This one here has got the same marking. This one's made in June 16 as well. So that's when it made. So it can't be older than that. So it's brand new. I've only got it myself, so it's going to be pretty much right anyway. Just interesting to see those kinds of details. So switch assembly. Got these nice contacts here. They are look like nickeled. I am not sure, but they're nice spring contacts. They're nice and springy. There's a lot of give in those. A lot of give in those. So those should last quite a while. They're very springy. So it's a bit of spring steel actually. Yes, it is. It's spring steel. So it's a bit of stainless or something. So yeah, it looks alright. The only real thing here is the fact you got this input right here with no real isolation. There's no slots in there. There's some flux switches on the board. Would have soldered those on. A little bit, you know, it could have been nice to clean it off, but the rest of it looks fine. But yeah, I don't know. I'm sure there's going to be people out there who can comment more on this isolation, what's going on. So let's see if I can see what's going on here. Right, so I decided to re-record this bit because I made a bit of a mess of it last time, so I'm doing it again. So in the protection circuitry for this, there's these thermistors and varistors, right, MOVs. So these are PTCs, positive temperature coefficient, if I can pronounce it properly. Right, so this is the diagram it's using for the actual circuitry for the input protection. So it's got two PTCs there in parallel, two MOVs in parallel, right? Those come through, and it goes to another MOV, which then goes back to negative terminal. Okay, so that's the connection there and there for the input to the actual meter to sense the voltages and so on, right? This goes through 3 resistors here, which is obviously for voltage input protection, to allow for high voltages, otherwise it could possibly arc across the actual part. So that's why it's 3 in series like that. Now these are the parts that's used. The MOVs are CNR07D561K, which equals a 560 volt 10% MOV. So 560 volts across that one, 560 volts across that one, so it's potentially 1120 volts before that will trip. Yeah, I guess that's alright. But the fact you got these like that in parallel with that one, it just seems a bit odd that they got that configuration. Maybe it's to do with current carrying capacity of these, or maybe, I don't know, but maybe it's why. But we could have put 2 of those in parallel and then with one MOV. I don't know, there's probably some reason for it, it's a bit strange. But and the PTCs are WMZ12A, which is stated as 250 volt DC, 265 volt AC. Now they've got different switching voltages just because they're thermistors, switching temperatures, but they aren't actually stated on here which version they are. It just has the main item code there, and that is it. Unless the green signifies something, I don't know. I'm not familiar with this sort of stuff, so I thought I'd just draw that out and show what that actually looks like, and explain what those part values are. Yeah. So basically, this can do. It can run continuously at those voltages just fine. Once it goes over voltage, it actually increase the resistance, but they're basically resettable fuses, and that's basically what they are. Right, so yeah, that's that. I can't, I'm not pretending to know much about that whole protection circuitry stuff. It's not what I do. It's not my thing. There'll be people which can comment a lot better on that than me. So if you know more about that than I do, then which is quite likely, please do comment and give your opinion on that circuitry. So there, drop that in there like that. Let's drop this back over here like this. And hopefully that display will still work. That's the risk of pulling things apart. So. Alright, But yeah. Hey, somebody put this together by hand, so you know there's a chance I can put it back together by hand without breaking it. Let's hope anyway. We'll find out shortly. Does it work when I'm finished? That's the question. So I did actually get asked recently, well, probably about a week ago now, by someone about doing reviews on some of my existing bits of test gear, and I was actually thinking about doing that anyway. Specifically, I was asked about doing one on the Vici, or VC, however you want to pronounce it, and I was certainly tempted to do that, but yeah, I mean the Vici is one I use as my main meter, purely because it's got a big bright display, and that's actually the reason I purchased it. Accuracy wise, it's not great. It's okay. It's, you know, it's not too bad, but the actual display is what I purchased it for, because it's a nice big display which is easy to see. Right, so I think that's in there. Okay. Now, part of me, right, is tempted to get in here and give these a twiddle and see if I can adjust that calibration for that 0.1 where it sounds slightly. It's so tempting. But if that's not what it does, I could mess it up. If it bothers me enough, I might change it. But yeah, it's so tempting. Even the fiddling of me. What is it? I want to go down properly. Something's holding it out slightly. I'm pretty sure I got that right. Might just be those spring contacts actually from the battery. Yes, all it is. That's fine. So yeah, so I was asked about doing test gear reviews on my existing gear, and I thought, well, you know, I could certainly do that. It was something I'd been thinking about doing, because I was thinking this new bits of gear and testing them and reviewing them and stuff like that. It's like, well, I've got all this other gear already here. I should really do some stuff on those too. So, when I run out of existing projects, although admittedly it's going to be a while, then I'll sit down and do review stuff on all my other bits of desk gear on my bench. Okay, do we have power? We do. Display all works. Yay. All good still. She's not dead, Jim. All good. It still works. Woohoo! Thumbs up. Now, subscribe, all the usual stuff. Give us a thumbs up. Tell your friends, share it. Whatever. I just want the channel to grow. And if anyone can do anything to help that happen, that'd be great. Catch you later.